So this is the image from the textbook, and it's actually pretty good, and it makes you understand this concept of aliasing and for that specific problem really well. So let's actually go step by step. Let's look at this signal. This is actually the original signal. This is just the cosine signal. That's all it is. This is the original cosine signal. And now what the problem tells you, it gives you A, B, C, D. Gives you actually 4 cases. We did 2 of them, but there are 2 more in the textbook. So A, B, C, D, omega naught is omega s by 6. That means omega s is 6 times omega naught, as I've written it over here. And this is pretty good. It's much larger than the Nyquist sampling rate. So what you do is that you sample at these points. Look at this point, this point, this point, this point, this point, this point. These are all the places where you sample. And if you have these samples with you, you can just interpolate the signal. And there are no issues in reconstructing the signal. And again, there are no issues in reconstructing the signal. If you have omega s equal to 3 omega naught, they give it to you as omega naught is 2 omega s by 6, but that's just omega s is 3 omega naught. You can see this is what the signal is, and these are the samples. This one, this one, this one, this one. These are essentially the samples of your cosine signal. And please note once again that there is no problem with reconstructing the signal at all. Things all look pretty good. And that's what it's meant by the fact that the sampling rate is larger than 2 times the bandwidth, and omega s is larger than the Nyquist sampling rate. So you can see here that there's no issues with reconstruction. But now let's look at case C and D. If you look at case C and D, you immediately see there's a problem. This is your original signal, but now your sampling rate is not very fast. You sample here, and instead of sampling somewhat here or here, you actually wait quite a bit and sample at this point. So you're already below the Nyquist sampling rate, and that's a problem. You should have been sampling and taking one more point at here, but instead you took a point here, and these are the sampling points that you have when you have omega s equal to say 3 over 2 omega naught. That's part C of the question. Now when you try to reconstruct the signal, you actually have the first point here, and then you're going to join it by this point. So your reconstructed signal is very different from the original signal because this endpoint is actually joined to this endpoint. Then you join it to this endpoint, then you join it to this endpoint. You've already completely lost all the squiggles of the cosine signal. And that's what is meant by not satisfying the Nyquist theorem and not satisfying the Nyquist sampling rate. You've completely got an incorrect reconstructed signal. Same thing with this, where you have omega naught equal to 5 omega s by 6. So omega s is just a little bit above omega naught. And then you clearly see that you're messing up. These are the samples which are equally spaced. These are kind of those train of delta functions that we have been using. And then if you try to join all the endpoints, you get a completely different signal than the original one because your sampling rate is not good enough. So I hope these 2 problems completely clarify the concept of sampling as well as aliasing. And we will be discussing more problems when we have the final exam review. Thank you.